next up is Wiesing from University of Barcelona. He's the head of this year's hackathon, and my personal reference whenever it comes to anything VR, especially Unity programming. So if you have like any questions to him, I mean, like that's the right person. Anyway, Michal, the stage is yours.
Thank you. Hello. I also had some slides. Yeah, right. So hello everyone. Today I will talk about rendering and realistic rendering in VR. But before I talk about that, I would like to give a short update on my last year's talk. So last year, I gave a presentation here about a project that we are working on in Barcelona about potential ethical problems coming with virtual reality. But last year we were just started with this project, so I couldn't present any data, and so today I'm happy that I can present some of the data of the first project. And the first project was about the question if we are at a risk to confuse what is real and what is virtual when we use too much VR. And I mean, this sounds maybe a bit like a discussion that we had already before, like with computer games, with movies and so on. There was always this discussion that we lose contact to reality, or that it blurs the boundaries. So why do we need to have this discussion again? And the reason is that virtual reality can give you a sense of presence. It can give you really a feeling of being at this virtual place, how present is traditionally defined. In more modern terms, we define presence as two independent illusions. So the first illusion is the place illusion, which is essentially this feeling of being there, or the sensation of being there, while you know that what you experience is not real. So it feels real, but you know it's not. And the other illusion is the plausibility illusion, and this is that the events you experience are really happening around you. So you're really at this place, and what is going on around you is really happening. Although again, you know it's not real. And these two concepts or two illusions are distinct from each other, but when they both occur, then we talk about presence, because then people tend to behave in VR as if the situation was real. Which is why we thought we should investigate this, because when we can make this strong sense of something is real, which is not, then the risk is maybe higher than when you watch a movie or something, that you confuse it reality with virtual reality. And so we invited 49 participants to participate in something we called interview. So it was just a cover story where we said we make an interview in VR, and the idea is we can make interview, for example, 100 people, but it's always the same way how they are interviewed without bias and so on. And this interview could be done by one of these two characters. On the left it was Matilda, on the right it was Liam, pre-animated virtual characters, and the experiment started with the participant put on the headset, and they were standing about here, and then the virtual character came, said, "Hey, hello, my name is Liam. I will do the interview today. Please have a seat." And this "please have a seat" was quite crucial, because we wanted to know how many people will sit down. And the thing is that this chair was, when they put on the headset, there was no physical chair. There was just a visual virtual chair. Of course, we placed the chair there in between. We asked participants, here, please navigate through the quest menu and start the application yourself to keep them a bit busy and distracted, and then we could move a chair at the right spot. And 9 out of 49 participants just sat down without checking. They were just sitting down, and this would be really, really difficult if this would have been a game you play at home, and because there's no one putting a chair there. So others were a bit more cautious, like touching first, is there something, or some were asking us, is there really a chair? But 9 participants, so almost 20%, just sat down. But this was not the only question that we had. So as I told you, we told participants this is about this interview application, but we said this is a user experience test, and we wanted to test, for example, if people get sick. So before starting the interview, participants answered on a virtual tablet in VR the simulator sickness questionnaire, just with their index finger, just typing on it, saying, here, I'm feeling fine, not so fine, etc. And after the simulator sickness questionnaire was answered, the virtual experimenter, or the interviewer here, Liam, stood up, took the tablet, moved it away, and put it into one of these 3 rolling cabinets. So this was counterbalance between participants, which one we used. And instead, he took out these buttons, which were used for the interview. And it was just the green button was when the participant answered a question, they press the green button to hear the next question, or the blue button if they want to rehear a question. Although this interview, as I said, it was a cover story, it was not really that relevant here. And then they answered 8 questions. The interview was about climate change, so like, what do you think about Fridays for Future, or of the impact of climate change on your mental health? And right after answering these questions, Liam stood up again, took the keys, put it away, and brought the tablet back. And again, we asked for answering the simulator sickness questionnaire. And once the questionnaire was again filled out, Liam stood up one last time, took the tablet and moved it back into the drawer and closed this drawer, and then turned around and said, hey, we are done, you can take the headset off, thanks for participating. And then afterwards, participants answered a lot of questions about presence and how they experience a virtual person and everything. And we asked them to come back to the lab a week later, but to a different room. And this different room looked pretty similar to what they experienced in VR. So the first session, they were in the real room, which was in a different building, and it looked completely different than the virtual room. And this real room also had here these 3 rolling cabinets. And then we told them that in the second session we would want to make this interview again, but in reality, without VR. And the first thing then was that the experimenter, the real person in that case, around, stood up and said, hey, I need to get the tablet, we need to answer the questionnaire again. But we deliberately looked at the wrong drawer and then opened the drawer and looked at, oh, where's the tablet? So where did they put it? So like, here you have seen in the pictures, this would have been the right drawer, so like we would start it here. And the question was, 1 second. And then the question was, if the participant will intervene and tell us, hey, you put it over there the last time, which would of course indicate that they reused something they learned in VR and applied it to the real world. So there was some kind of confusion in this sense. And this happened with 22 participants who did this. And by the way, we asked participants, they all remembered where the tablet was, so they all learned where the tablet was. They also all recognized the room, that it was looking like the virtual environment. And 22 of them really said, hey, last time you put it, it was put over there, look there. So we did some analysis on this with a Bayesian model to get some ideas of real-world populations, so how many people in reality would maybe confuse in a similar way VR and reality. And for this chair interaction, there was a 95% probability that between 12 and 34% of the participants, of people, would sit down. And the probability is almost 1 that 10% will sit down in a similar interaction. When you just ask them here, please have a seat. So this is really something you should consider when you do interactions, so maybe do some UI that they should press a button to sit down and not physically sit down. And for the tablet interaction, the 95% probability was said that between 32 and 58% of the participants would intervene and confuse in this sense reality and virtual reality. And again, the probability was almost 1 that at least 25% would do this. And as I told you before, we think that the reason why people confuse this is presence. So we wanted to look if there is a correlation between the confusion and presence. And we made a lot of notes how participants behave. So like, did they just sit down? Did they touch this chair before, and so on? That we put into a model. And then we looked if we can correlate this with presence. And first we did this with a place illusion, so this feeling of being at this place. And here there was no correlation, which was a bit surprising to me. But we also looked at the plausibility, and plausibility in 2 ways. So we asked 5 questions about the plausibility of the environment, so how real was the environment perceived, and 5 questions about the virtual experimenter, which we call here the other. So how real or how plausible was the virtual person experienced. And when we look here, so when there's a high plausibility of the environment, but a low plausibility of the character, people confuse more than compared to when it's the other way around, which totally makes sense, because these factors where people confused reality and virtual reality was regarded to the room and not to the character. But what was then a bit surprising is when both is balanced. I mean, when both is high, the plausibility of the room and the environment is high. This is what we expected, that people confuse that. But here it's the other way around. It was lower. I mean, when both is low, the plausibility, there's no reason to assume that there's a confusion. But also when both is high, it seems that the confusion is less. Yeah, this basically suggests that what we think is that when the realness of the environment is consistent, high or low, then you experience this as a separate reality. So you can really separate it from reality. But when you have this mixed condition, so the virtual environment seems to be super real, but the character seems to be not real, then you're like in a cognitive dissonance where one part of your experience feels real, the other one not. And we think that at least our data suggests that this is what leads to confusion in the end. And with that short update on my last year's talk, I want to talk about realistic rendering in VR. And something I'm working on right now, a guide to help people to get started to develop virtual environments. So when I started with all of this, this was about 8 years ago, before my background is in cognitive neuroscience, and before my experiments looked like that. Some gratings with different colors, orientations, and spatial frequencies, a fixation cross in the middle, that's it. This is something you can create with a few lines of code and CyclePy. But then I tried out a friend's Oculus Rift CV2 in I think 2014, 15 or something, and I thought, hey, this is really cool for research. But suddenly I had to develop not just my stimuli, but meaning to make a world around it. And the first virtual environment that I developed, there was the idea to recreate a small test chamber we had in the lab. And this was the very first prototype. So, I mean, it looks a bit similar, but it doesn't look good, and also it doesn't really represent this room. And it took me, it was a side project for more than 2 years, so the idea was quite old, but there were other projects coming, had high priority. So for 2 years where I just had to, where I could come back to the environment and try to get these details right. And so I could, over the time, improve it, and I think could at least get quite close to get the look of the real room. So and since then I developed quite a few virtual environments, and I really enjoy doing this graphic stuff. It's one of the best parts of my job, to be honest. A part, of course, from talking to people like you here. And this is why the idea was, because I don't have had any training when I started to develop virtual environments or to use game engines, use VR. And so the idea was to write some high-level guidelines, so not a tutorial that tells you which buttons to press. There's enough stuff online that you can look up there, but really on a high level to explain concepts which are important to. So basically, it's a collection of things that I learned over the last 8 years, and where I would have been happy if someone would have told me 8 years ago, hey, look first at that, spend more time on that, and don't think too much about this or that. And the idea is really to provide this high-level overview for creating realistic environments and how to optimize them. So because when we have real-time rendering is really complex and demanding. And in fact, much of the things we do in real-time rendering is not in real time. So whatever we can do, whatever we can pre-calculate, we do pre-calculate, because we want to offload as much as possible. So in the end, real-time rendering is actually a mix of something happening in real time and happening in pre-calculated steps. And because of this, the first rule when you develop a virtual environment is optimization. Optimization is key. So especially in VR, because in VR people, get motion sick when they are lax. So you don't want to make them sick. It does not degrade the quality of a VR experience. But when you do, for example, an experiment, it also affects how people behave, and it will screw up your data. So always hit the target frame rate, and there's, in my opinion, no excuse when there are frame drops. So there should never be a lags, and this is possible to develop virtual environments which look good, look realistic, but they run well. One thing that you should always do is to profile your app. So like here, this Oculus VR metric tool is one example. So therefore other companies like Pico, they also have these kind of tools where you can see in VR, you run your application and run this as an overlay, and you see different kind of information. For example, here, how much workload is on the GPU, how much workload is on the CPU. And this is something, for example, I would always try to optimize things that here, this never exceeds a number of 90%, so that there's a headroom that you don't run into frame drops. But it also counts how many frames were late, how many frame drops did you have, like here. So really use these apps and don't just test it on your own. So what people often, I think, do is just they put on the headset, they move the head, and so yeah, it's all smooth, fine, it's optimized. But this can be highly wrong, because there are a lot of things going on when you have bad performance to smooth of head movements to not make people sick. When you don't have something like that installed, a better way is move your hand, because we don't smooth the hand movements when they are frame drops. So when the hand moves smoothly, it's a good indicator that the performance is mostly well. But when the hand is shaking, then something is wrong and you need to optimize it. But then the second rule is don't over-optimize. You have a certain amount of performance that you can spend on rendering, and as long as your environment is not perfect and you don't see anything to improve, and in my experience this is never the case, then use the resources you have. And with optimization is also, this is something in the paper, I'm working on this paper right now, there will be a preprint out in a few weeks hopefully. I explained that one important thing what I mentioned here is that it's not all about polygons. So polygons are when you have a 3D model, we have actually a mesh of points connected with edges, and in between we have these faces, which we call polygons. And I have the impression that many people, when they think about optimization of VR, the first thing is that they think is, okay, we need to have less polygons. But actually, with modern hardware, polygons are by far not your worst problem, and you can go with quite high numbers, actually. And one other thing is when we talk about polygons, you see these are all quads, so there are all 4 edges in each face. But as once your model is rendered on the GPU, it's all divided into triangles. So the number of polygons here would be twice as much as what you have seen in that picture. So when you look at the number of polygons of a model, look what is the number of triangles. And when you want to know what is a good number that you can render on your system, so like here for Oculus, but also other companies, they provide you with information, with guidelines, what is possible. Of course, these are just some abstract numbers, so like how do 500,000 polygons look like? It's of course not easy to imagine. But to give you an idea, this environment completely consists of 130,000 triangles. So there would be, even from the number of triangles, it could even run on. Okay, I need to hurry a bit, Art says. Okay, but this is really, you can go for realism. You don't need to have this low poly, reduced polygon look in your scene to have a realistic looking scene that performs well. There's one difference when we talk about avatars, for example, or every 3D model that can deform, because then we need to, you have seen these vertices, these dots, or these points of a model, and we move them back and forth when we animate, for example, an avatar. An avatar is in the end also just a mesh like this sphere, and this is more expensive than when you have a rigid body that you render. So be a bit more wary with trying accounts for avatars, but even here you don't need to go so low that you see some kind of low poly image. So it can be like here, be all round and look realistic. And then when you develop a scenario, you of course need content. You need like you have seen this EEG chamber. In that case, I modeled the scene and also made textures and so on. But you don't need to do that. You have stores where you can buy or purchase assets, like on the Unity asset store on the Unreal marketplace. And what I want to mention here is, no one is forbidding you, for example, to use something you bought for Unreal Engine to use it in Unity. And in my experience, the Unreal marketplace has a way higher quality assets than Unity. So I don't know the licensing from Unity, if you can use that in Unreal, but the other way around is definitely possible, because I do that constantly. But so, and then one thing, I often in papers, I have the feeling when I see virtual environments, I think, okay, this environment is really big. Why do they do it so big? So the bigger your environment is, the more stuff you need to put into it to make it realistic. Otherwise, you have a huge empty space. But the more things you have in your scene, of course, the more you have to calculate. So it will degrade your performance. And one thing, of course, is you measure a real room when you create a virtual room, and then you get realistic scale. But a more intuitive way is, so what I always did in the first environment that I developed was, I started with walls, like in the real world. You make a house or you make walls, and then you put stuff into this. But in VR, don't do this. First, put something that is scaled appropriately to the real world, and this gives you a sense of scale. So then you would see that this plane here is quite huge for a living room, so it could be way smaller. So just put some objects in your scene. It can be deleted later. It just needs to be something that gives you real world relevance, real world scale, so an idea of scale. And then you put your scenes together. So like you get models, you model themselves, you get them from the asset store. So then when you want to have realism, of course we need to define also how the surface reflects to light, responds to light. And this is done with so-called physically based rendering, where we have different features that we can manipulate of the surface and define how light is reflected. Like you can define how shiny, how specular the surface is, or the roughness, or if it's metal or not. And what you see here is, for the sphere, there's always one value for the whole model, where you just say, okay, this wall just has this roughness, it has this color. But if you want to go for realism, don't do it like that, where you just set a value, but instead work with texture maps. So like here, when you have this chocolate center, this is basically our texture. We wrap around our model, and then we can, for example, have different colored areas on the model, and not just one color. And also this could be done for the roughness, or some part could be a metal or not. And to give you an example here, this is, you want to make a sidewalk and you want to have some pavement stones. Here I applied a color map, which is the first map you apply, but there's not just one texture map that you use for your surfaces. There are more maps, and one example is the normal map, and this is something you should always, when you have normal maps, apply them. A normal map is essentially just a depth map, where you can tell, okay, this part is lower, this is higher, and you can create this fake depth. So this is still one plane, there is no geometric depth, but just applying this normal map greatly enhances the realism or the depth of it. And you get these kind of texture maps for free on, for example, Ambient CG. This is my to-go library. These are all completely free Creative Commons Zero assets. You don't need to an account. You just choose what you want to have, and then you can download different kind of maps to create these visuals. Like, for example, when you have this rusty metal, so you would have a map not just for the normals or for the color, but also for the roughness, where these rusted parts have a higher roughness than these not rusted parts, and so on. And in reality, we always have surfaces, always have imperfections, and we can only create these imperfections when we use texture maps, and not when we just apply a plain color to a surface. And yeah, this is all free. It's super easy to implement. And really make use of it and use more texture maps. So in papers I often see really these super plain, smooth walls or floors, but reality is unfortunately quite messy and not like these standard virtual environments. And that I come to the last part, what I want to talk about today, and this is light. And when you want to improve your realism or the virtual scenarios in general, learn how to do light. It's unfortunately it has a bit of a learning curve, but it's really worth it. It's not just that you get better visuals, but you also get the better performance when you do everything white. So it's a win-win situation, because light is really complex and difficult to calculate. And with current technology, for VR at least, so for desktop rendering it's currently changing, but for VR, the only thing we can do in real time is something like here, what you see here. This is the so-called direct light. It's like you would use a flashlight and point it to the wall, and then you see a bright circle on the wall. But there is no reflection of the light, but light is more complex, so photons bounce around. So here, it would also, the parts which are not directly lit would be illuminated. But this is something, this is super complicated to calculate in real time. And so this is something we need to pre-calculate if we want to do it right. And this is so, to give you here an example how this would look like. In this chamber, there's just one spotlight from the ceiling, and this is just right in real time also. We just have light to the bottom, but you cannot see anything from the ceiling. With global illumination or this bounce lighting, it looks like that. And it's not just that it looks better, but also, okay, I was a bit fast. So and what we do for here is, again, we use with maps or with textures. So before, when you develop your scene, you just set up your light, and then you tell the computer, okay, now make textures with light and shadow, and you just put these textures on there. This is, as I said, it has a bit of a learning curve to do this light mapping, but it improves your visuals, but also your performance. So one thing you can see here, so this scene has, as you can see there, 56,000 triangles. If you go here to the scene with the real-time lighting, we have 130,000 triangles, so more than twice as much. And this is because when we calculate shadows, a shadow is not the absence of light in a real-time rendering, but we need to actively calculate shadows, and we need to calculate the whole geometry twice. And this, which is why when you bake your light, you would really improve here also the performance. And with that being said, I am a bit short of time. In the paper, this will be all way more detailed, and also here I just could make some examples. But yeah, actually, it would be great if we would have collections of environments that we could just freely use. The problem is when we use assets, for example, from the Unity asset store, we cannot share the raw files later. We could make a game out of it, sell it, but we cannot just share a texture or 3D model, which is why, which makes it also hard to share experiments after doing it, after conducting them. And here I created a project with currently 5 different virtual environments and uploaded them to GitLab, which are right now ready to use, can be downloaded, including this test chamber, or here the so-called visitors room from the confusion experiment I just presented, or the living room you've just seen, and maybe also a room that might be familiar, you're just sitting in that. So a replica of this environment, of this atrium here. And lastly, currently there's also something that is supposed to look like the Pantheon in Rome. And environment number 6 is in the works, and you can download these on GitLab. Just search for Event Lab, and then the project is called Open Environments, or currently, I don't know how long this link will work, but tinycc.vr summit, and you can download these environments. And this is all Creative Commons 0, so do whatever you want. You can make a game out of it, you can, whatever you want, there's no restriction at all. You can share all the files. And if there are some questions, just write me an email. And also, if you're interested in the paper, so I would let you know as soon as the preprint is out. When you want to read the guide, then just write me an email and I will let you know. And with that being said, thank you for your attention.